Good afternoon. I'm gonna take you through a process of creating a water network system that works. Basically, we have been given a project by UNISA, by Mr. Yulunga, semester 1. We're instructed to create. The learning outcome of this project by the end of this unit, we will have learned to download and install freely available water supply network design software by the name of Epanet. We would have learned as well how to apply the software to undertake basic design calculations. A typical bulk water supply network in South Africa comprises of abstraction and water treatment, works, pump station, reservoir, and pump lines. So we have a basic layout here, where we shows the 5 townships that will need water, and they will be receiving water from the Ngwengwe River upstream to the townships. Those are the water demands for each particular township, and that is the general layout with the heights and pipe lengths and your bulk storage, water treatment plant, and your river taken as your datum. So I'll basically go through these steps as I go through them, showing you through the software. I've opened Epanet right now. So basically we'll have to just know our different components that we use. We'll have to set up a water network as compared to the one that is in the project brief. So I'll start off with my reservoir, and then I'll have my water treatment works. Then I'll have my storage. Then I'll have my first node. Then I'll have my second node, which will be my junctions. And my third junction. Then I'll have my demand center, which is the townships. And then a second demand center, which is the townships. A third, a fourth, and a fifth. Then I'll link them. It was required within the project brief that we have 2 pumps. If we look at the layout, you will see from the river there will have to be a pump that takes water to the treatment plant and essentially to the bulk storage. From there, using that pump's energy or power, it will distribute the water to the junction and ultimately flow into the demand centers. So I will store my pump. my second pump. And then from there I'll put in my pipes. Pipe to junction, pipe to junction, pipe to demand center, pipe to demand center, pipe to demand center, pipe to demand center, pipe to demand center. So this is basically us just setting up that network. And then obviously from there, we will have to size the system. So we're given lengths and heights, but firstly, we had to calculate the heights, the elevations of the different, the elevations of the different storage and demand centers and or junctions, the elevations as compared to the river. We take the river as 0. Now the heights that were given here were heights above sea level, as written there, meters above sea level. So we had to do a calculation. I'll just give you the calculation of the different heights. There we go. So set elevation to nodes are as per datum being 0.0. So we've been given the river as being 0, and all of them will be compared to that of the river. So now this will be our new heights that will be set into our system for all those centers. Well, centers, junctions, and bulk storage, and your water and river. Okay. What we'll have to do, I'll just make an example of how we would go about maybe, let's say, setting an elevation. Okay. So we'll say that head is at 0 of our reservoir, and then we have a default setting already. So, but then we're going to set our elevation of that treatment works, which will be what now? If we check here, our treatment works, as it says there, is at 17 meters. So we put the 17 meters. If we go back to our layout, we can see, okay, basically all of the, I'll set heights for all of them. And now I'm just going to demonstrate how I will set the length of a link. A link would be a pipe. So I'll click on the link and then I'll look at the length. We have a default setting already here of 1,000, but then our brief has given us that we must set our length at 1150 meters. So I can set that one at 1150 meters. Our brief has also said that we must set all pipes at 300 diameter. So the quickest way to do that, if it says all, we'll go to edit, select all, and then edit, group edit, and then we say all junction, all pipes diameter, and then we want to change the diameter and all set them all to 300. So 8 pipes were set up to 300. So basically that's that, and you set your height to that, and then now I'm just going to go to the project that I've recently just worked on, just to speed up the project. So I'll just see this one as simulation for presentation sake. Okay. So now this is the system that I have worked on. Basically looks like what we've worked on right now. I'm just going to change maybe that diameter to 300 for presentation purposes, so that we can see that when we run the analysis, it's rather you run the analysis there, or you can run the analysis here, and then it will give you a warning message which tells you that there's pressures within the system, negative pressures within the system. So now we want to see these negative pressures in the system. How do we do that? We go to view map, pressure, and then it will show us those negative pressures. But bear in mind, we had also set up a pattern here, a time-based pattern. Okay. So that pattern, that one, is what we've set up in the system. So it would mean that flow is not always the same all the time. Okay. How do we view that? We view those pressures as water flows during the day. So we can go play there, and then we can see the pressures are changing. So they are not equal at all times. So what we have learned is that we will need to change the different pipe diameters in order for us to reach a conclusion where we get a successful water network. So what do? We go back to that pipe. Since I know it's my pipe, yes, I'll just take it back and then run the system, and the running system is successful. Okay, and you see now there's no negative pressures. As well as you play, you go and see that, oh, now the system is running. You see the clock is running. The clock is running, and there are no negative pressures found throughout. So, what are other components that were in the project brief? In the project brief, we were instructed to also go and set up the hydraulics to liters per second and has a William equation. So on data, we go to on options, we go to hydraulics, and then we have set up the Hazen William and liters per second. Okay. We're also told to set up time. So we set up the 72 hours and a time step of 4 hours. We're told to also go set up the patterns, and then we uploaded those values as given and saved it for future purposes if we want to use it in another system. And then pressed OK. We're also told to set up the pump curve. At a volume of 59 liters per second, which is the flow, and a head of 75 meters. And then we save that. We've already gone through the process of saving the the diameter or 300, but that was before we ran that simulation. And then we've also been requested to set the tank storage. So now you see the tank storage. It says it must be at a storage capacity of 10,242 meter cubes, of which we've allowed for 12 meter high and a diameter of 34 meters. And in essence, there is 34 meters for your storage. And when you do your calculation, we will see that we have a volume of 10,895, which is more than that minimum that was required. And then we run the Epanet. After running the Epanet, we get a successful. So those results will basically be looking for them in the graphs. We can see your time series, of which if I want to see for that tank, and I also want to see for the other tank as well, I can just go see that time series of pressure for selected nodes. So this will be your time series for your tanks, how pressure is been moving. We can also add pressures at your let's go back and select the graph time series. We want to see your pressures at your demand centers. And maybe just another node, which is a junction. We press OK, and then we get your time series, you get your pressures. So yeah, that's basically it, as well as those results. One other thing, we can go through our project report. This was prepared by Justinius Masemola, which is me. My content will include an introduction, objectives, literature review, system, workplace, methodology, problem discussion and mitigation, results, conclusion, and my references. I introduced and I've placed my objectives as instructed in the project brief. I've shared the literature or information regarding the components that are in Epanet. The system workplace is basically how you can see how Epanet works and is displayed in my presentation, as well as the different components that you'll be going through explained. You will see how I've named and set up my system. You will see the elevations as I've set them out and also as I've calculated them. You will see my hydraulics, time, pattern, curves, and size tanks, as you have seen how I've shown them on the presentation on Epanet. Shows the different lengths that were set, first analysis that failed, and then we'll go to the discussion of how Epanet will give you certain warnings at certain times. It depends on the type of project that you'll be running. And then we'll run another analysis after we've gotten our solution. And ultimately, we'll go look at the objectives that we're looking for, which is the flow rate, the flow velocity, pump heads, which is presented there. Flow velocity, pump heads. We will discuss the results as well, where we see your elevation, base demand, demands, head, pressures, and your network table of results with adjusted elevations, and then your system flows. Those are just the results, and we'll go through all of those in the report, and then we will conclude by expressing how we felt of using this software and the typical simulation period, what you call the project report that can be produced. And then ultimately we will conclude and give our references.